Hello everyone, I am Dr. Krishna Sarker. Here in this session, I'll be going to discuss about signal flow graphs technique. Example number 1. This is linear control systems. Lecture series on linear control systems, lecture number 29. So our topics, signal flow graphs techniques, example 1. Signal flow graphs from block diagram. Example 1. Draw the signal flow graphs and find overall transfer function C of S by R of S, where CS equals to C of S equals to controlled output or effect, and R of S equals to reference input or cause or excitation. R of S equals to excitation. And this is maybe step, ramp, parabolic impulse, sinusoidal, any type of input you can apply. And the transfer function R of S. So R of S equals to reference input. And this is the forward direction, always positive. This is summing point or comparator. Another summing point or comparator. And the gain of system G1S, first gain, and the second gain G2S. This is the another summing point or comparator. And the third gain G3S, and the controlled output C of S. So this is the forward path. And then this is the feedback, and this feedback, negative feedback, H1S feedback element. Another feedback, this is also negative feedback, and the feedback element H2S. Third feedback, this is also negative feedback, and the feedback gain or feedback element H3S. So this is the block diagram. Our target from this block diagram to signal flow graphs and overall transfer function C of S divided by R of S. That means Laplace transform of output divided by Laplace transform of input. This is the overall transfer function. This is figure A. Solution. Step 1. Select the nodes as follows. First, select the nodes. There are 7 nodes. The input R of S and output C of S are represented by nodes. So first point, this is the R of S, and this is the C of S, represents by nodes A and B. A and B. Then the first, second, and third node summing point. This is the first summing point. This is the first summing point. Summing point 1, summing point 2, and summing point 3. So first, second, and third summing points are represented by nodes B, C, and E respectively. So this is B, this is C, and this is E. The first and second takeoff point are represented by nodes D and F. So which one first summing takeoff point? This is the first takeoff point, and this is the second takeoff point. And first and second takeoff point are represented by nodes D and F respectively. So this is the step 1, total 7 nodes. signal flow graphs from block diagram. Selection of nodes. So first point, selection of nodes. RS reference input, summing point, again summing point G1, G2, gain, third summing point, G3, third gain. This is the feedback and feedback element H1S is negative feedback. Again H2S, and this is also negative feedback, and this path also negative, and the feedback gain H3S. So selection of nodes. RS, node A, first summing point node B, second summing point node C, first takeoff point node D, third summing point node E, and the second takeoff point node F, and controlled output or output node G. So this is A summing, this is the input node, this is the first summing point node B, and the second summing point node C. This is first takeoff point node D, and the third summing point node E, and the second takeoff point node F, and the controlled output node G, or overall output node G. So 7 nodes A, B, C, D, E, F, G. Then step 2, selection of forward paths. Only forward paths, only one forward path in this problem. This is the forward path in block diagram. A, B, C, G1, G2, D node, E node, then G3, node F, and C. So RS to C, this is the forward direction or unidirection, just that's why this is the first forward path. In this problem, only one forward path. This is the forward path, A, B, C, D, A, B, C, D, E, F, and the last point G. Then this is the feedback path, H1S negative, second feedback H2S, third feedback H3S, this is also negative. So first draw forward path, only one forward path, RSA, then A to B branch gain 1, B to C branch gain 1, again B to C branch gain 1, and C to D, this is the C point, this is D point, and the branch gain G1 and G2, these two gain actually G1 and G2. Then D to E gain 1, E to F forward gain Z3, and F to Z forward gain again 1. So this is the forward path. This is the forward path. So forward path either A, B, C, D, E, F, G, or RS 1, 1, G1, G2, 1, G3, 1, and C of S. The first forward path, this is the path RS1, 1, G1S, G2S1, G3S1, and C. And the first forward path gains are P1. This path gain equivalent to P1 equals to Z1S. This is the Z1S, Z2S, and Z3S. G1S, Z2S, and Z3S. This is the first forward path gain. So step number 3, selection of feedback path. 3 feedback paths in this problem. So first draw forward path. This is a forward path, and This is the first feedback path. This is the first feedback path. So this path, this is the first feedback path. And again, this is second feedback path. And this is the third feedback path in block diagram. But for signal flow graph, A, B, C, D, F, G nodes. So draw first forward path, A, B, C, D, E, F, G. And this is the first forward path, feedback path. This is the first feedback path, and the gain minus H1S. This is the negative feedback. That's why this is minus H1S. And the second feedback path, this is the second feedback path. So the gain of feedback minus H2S. And the third feedback path, this is also negative. So this is minus H3S. Three feedback paths. This is D, B branch, and this is the FE and FC, actually FC. So next point, step number 5. There are 3 individual loops. Total number of individual loops. This is the starting point. This is the forward direction. And again return, same point. So this is loop. And this is the L1 loop. Again, this is the starting point. And this is the unidirection. Feedback. Again, return this point. So this is second loop. And another loop, L3. This is the starting point. And this is the loop direction. So L1, L2, and L3, total number of loops equals to 3. So draw first loop, B point, then branch gain 1, then C point, this is the C point, again D point, and the branch gain G1, G2, and the feedback element minus H1S. This is loop number 1. So the loops gain are G1, G2, and H1S. So minus G1S, G2S, and H1S. Then second loop, starting from E node, and the gain of branch G3S. This is the F node, and this is feedback minus H2S, and loop L2. So L2 equals 2. The loop gains are L2 equivalent to minus G3 into H2, because minus H2S. Actually, G3S into minus H2S, or minus G3S, H2S. And the last and final loop L3, starting from C point. This is the C point. So C to D, G1S, G2S, C to D. This is the C to D point. And the D to E, 1 gain, and E to F, G3, and F to C minus H3S. This is H3S. This is H3S. Then this is a loop number 3, and the loop gains, this is G1S, G2S, G3S minus H3S. So minus of G1S, G2S, G3S, and H3S. So total number of loops equals to L1, L2, and L3 individual loops. And in this case, step number 6, there are 1 pair of non-touching loops. So what is non-touching loop? This is the forward path. In this forward path, this is loop number 1, this is loop number 2, and this is loop number 3. And in this case, loop L1 and loop L2, non-touching loops. So calculate the non-touching loop gains. So first, draw forward path. B, C, D, and the gain of B, this is point C, this point equivalent to C actually, this is C point. So BC gain equals to 1 and CD gain equals to G1, G2. And again, another loop, E2F, Z3 gain, and the feedback gain minus H2S. This is loop number 2. And L1 and L2 equivalent to what? The loop gains are L1 into L2. In this case, Z1, Z2 minus H1, and in this case, Z3 and into minus H2S. So Z1, Z2, Z3, H1S into H2S. This is the loop gain, non-touching loops gain, non-touching loop gains. So next, step number 6, calculate delta, delta calculation. Delta equals to what? What is the formula? Delta equals to 1 minus sum of gain of individual loops. In this case 3 loops, plus sum of gain product of possible combination of 2 non-touching loops minus sum of products of all possible combination of 3 non-touching loops. Similarly, next point, 4 non-touching loops, 5 non-touching loops. In this case, delta equals to 1 minus L1 plus L2 plus L3 plus L1 into L3, because sum of gain of individual loops, sum of gain of individual loops equals to L1 plus L2 plus L3. In this case, this is L1, L2, and L3, individual loop, sum of gain of individual loops. Then non-touching loops, L1 and L2 non-touching loop, L1 and L2 non-touching loops. So this is the L1 and L2. Then 1 minus, put here L1 value. L1 equals to what? L1 equals to Z1, G2 minus H1. So Z1S, Z2S, H1S, and plus L2. L2 means this gain. So Z3 into minus S2S. Similarly, minus Z1S, Z2S, Z3S, and H3S. This is the third loop gain. Third loop gain plus individual loop gains. That means this into this minus Z1, G2, H1S, and G3 into H2S minus. So this is the delta. Delta equals to ultimate 1 minus L1 plus L2 plus L3 plus dot 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 L1 into L2. Then step number 7, Mesons gain formula. What is the Mesons gain formula? The overall transfer function T equals to CS by RS. That means Laplace transform of output divided by Laplace transform of input. And in this case, all initial conditions are zeros. This is called overall transfer function. And in this case, Mesons gains formula K equals to 1 to K Pk del K by delta. In this case, K equals to 1 to K. Put K equals to 1 and del equals to 1. So P1 del 1 by delta, because in this case, only one forward path K equals to 1. That's why K equals to 1 and P1 del 1 by delta. And delta equals to 1 minus L1 plus L2 plus L3 and plus L1 into L2. That means this is the non-touching loop gain. And this is individual loops L1 plus L2 plus L3. Then put the value P1. P1 equals to what? P1 equals to already proved G1 is into Z2S into Z3S. Then 1 minus put G1, L1. L1 is equals to G1S, Z2S, and H1S. And L2 equals to minus Z3 into H2S minus L3 equals to plus L3 equals to G1S, Z2S, Z3S, H3S. And L1 into L3 equals to minus Z1, Z2, H1 into minus Z3S into H2S. So this is the transfer function for given block diagram by using Mesons gain formula. So this is the easy techniques. In this case, P equals to what? P1 equals to Z1S, Z2S, Z3S, L1 equals to minus Z1S, Z2S, and G3, H1S, L2 equals to this and L3 equals to minus G1s, G2s, C3s, H3s. Put this value and the overall transfer function or final transfer function Cs by Rs equals to, this is the value. In this case, this is the P1. So this is the P1 value, 1 minus L1. This is the L1 value, and L2, L3, L3. So thank you.